All right, we got here our review stations, and I'm going to go through these pretty quickly. If anything's confusing, just give me a comment or talk to me, and I will do it slower. Okay? So we're looking first, are each of these a function? Then we're talking about domain and range, and then we're talking about if it's a function, what is the value of f of -1? This is a function, this is a function, because every x value has only one y value. The domain and range of the line are all real numbers because we're making the assumption that when it touches the edge of the picture, it continues on forever. If it doesn't continue on forever, then the domain would just be -5 to 5, and the range would be -5.5 to 9.5, assuming it hits halfway in the boxes. The domain of this one is the set of x values such that -2 is less than or equal to x is less than or equal to 1. And the range is the set of y values such that -1 is less than or equal to y is less than or equal to 2. The value of f of -1 is about 3.5 for this one, because when I go to x equals -1, my y value is about 3.5. The value of -1 on this picture is -2, because when I go to x equals -1, my graph is at -2. Let's take a look at the other two. Okay. This one is not a function because when I look at a certain x value, like for example x equals 2, it hits the graph twice. This one is a function because every x value will hit it only once. The domain here and the range here are the same. The only difference is that domain talks about the x values between -5 and 5, because that's the furthest left that the circle goes and the furthest right. The range also goes from -5 to 5, but it talks about the y values. I don't need to answer f of -1 because it's not a function. On the last one here, the domain is all real numbers for the x's, so I could just write this a little faster, because my parabola never stops going to the right and it never stops going to the left. The range is the set of y values such that y is smaller than or equal to 8, because that's the vertex and it never goes above that point. It's optional, it's not necessary, but you can also put a negative infinity on that side to show that you understand that it goes down forever. On this one, f of -1 is kind of hard to tell because the graph counts up by 2's. I'm going to guess it looks like -5. Just asking you, what is the y value when x equals -1? Okay, scooting on down, domain and range again. We have the function f of x equals 2x minus 1, and we're given a domain, and we're asked to find a range. Well, that means we plug it in. If you plug in -2, -2 times 2 makes -4, minus 1 makes -5. Plug in +1, 2 times 1 is 2, minus 1 is 1. I'm actually going to assume that they meant -1 here on this problem. It's just a typo, which brings our answer down to -3. If you plug in 0, you get -1. If you plug in 1, you get +1. If you plug in 2, you get +3. So that's the range. Those are the y values that I get out as answers. If I look at the second problem, I have 0 up to 4, including all the values in between. So my range is also going to be an interval. If I plug in 0, I get -1. The answers I get out are called y values. If I plug in 4, I get 7. That's the range. If I'm allowed to plug in all real numbers, then there's no limit to the answers I can get out. Every real number could be got as an answer, so all real numbers is my range. Now, on the next part down here, we are just flipping the question around. Instead of me telling you what the domain is to plug in, I'm telling you what the range is. So now you just solve. Solve 2x minus 1 equals 3. So add 1 and divide by 2. X is equal to 2. I'll solve one more, and I hope you'll see a pattern. Add 1 to both sides. Get x is equal to 3. Notice that those values are going up by 2, which is also the slope of f of x. And so I know that my domain is just 2 3, 4, 5, and 6. That's the domain that would give the range. Very similarly, I have to solve 2x minus 1 equals negative 1. Add 1, divide by 2, and I get my my domain. 0 is less than x is less than or equal to 2. I already solved the equals 3 problem right here. All real numbers we already talked about. I went pretty quick. If you want me to talk more about problems like that, just let me know. Now we're graphing functions and inverses, but we're specifically looking at the domain from negative 3 to 3. So I'm just going to add an axis in there, and I'm only looking at in between negative 3 and positive 3. So 3 minus x means I have 3 minus 0, 3 minus 1 is 2, 3 minus 2 is 1, and this graph comes down here, and it goes all the way up here to 6, okay? That is the original graph. Now I'm going to graph the inverse. The way you get the inverse is you switch those points. So this point right here, negative 3 comma 6, actually I should make that in red because that's on my original graph. That's going to flip around to an inverse point of 6 comma negative 3. So 6, negative 3. Original graph had a point of 0 comma 3. Inverse graph is going to have a point of 3 comma 0. I connect those two. However, my purple graph stops right here because the range of the purple graph needs to match up with the domain of the original. So they overlap for this zone here. They don't overlap for their entirety. Visually, when you graph an inverse, it's going to graph over the line y equals x. It's going to reflect over the line y equals x. And you can check for yourself that those do match up with each other. Same sort of process for number 2. 2x minus 1. 2x minus 1 means we start down here at negative 1. We go up 2 and over 1. We only go between negative 3 and positive 3. So I'm going to go a little off the grid. Then I'm going to take a couple points, like for example, 0, negative 1, and 1, 1. And I'm going to I'm going to reflect those to make negative 1 comma 0 and 1, 1. And my purple graph is only going to go down, so it's got a half of a slope. And it's going to go down to y equals negative 3 and up to x equals positive 3. And it's not going to go beyond those points. Okay, let's do the next one. Similar. We have negative half x plus 2. So there's 2. I go down 1 over 2, down 1 over 2. I guess I went too far. I only want to go to 3. Remember, we're still just going between negative 3 and 3. So that's my endpoints. I just need to grab a couple points. 0, comma 2, 2, comma 1. Flip those around. 2, comma 0, 1, comma 2. Only going, now we're going down 2. So I want to go down 2 and another one. I don't want to go past 3 and negative 3. So I think that looks good. And the last one's real similar. At this point, you've seen it several times. Here is 0.5x minus 3. Start down here, go up 1 over 2, because that's what 0.5 is. This one's not going to fit on there, so I'm just going to... Oh, I messed up. I want to only go between x equals 3 and negative 3. So I can screw rid of that. That's x equals 3, and then negative 3 means I go down to right about there. And then my purple graph, I'm just going to take, instead of 0 comma negative 3, negative 3 comma 0 instead of 2 comma negative 2. You got negative 2 comma 2 only going up to there and down to there. Beautiful. Some of the finest lines I've ever drawn. Okay, now we got linear situations here. Whenever you've got a word problem, I want you to check what's the rate of change among the y values and what's the rate of change among the x values. I've noticed it goes plus 7 and then it goes plus 8. I just did 12 minus 5 and 20 minus 12. Here this goes up 525 and this goes up 600. And then check, what's your slope? 525 divided by 7, 600 divided by 8. 600 divided by 8 is 75, and so is 525 divided by 7. I think. Let me double check. Yeah, 75. Should have known. So we know that the slope is 25. So we know that the slope is 75. So we can write our model. We can write our linear equation. Y minus 1575 equals 75 times x minus 5. It's just point slope form. I have been trying to convince you that point slope form is easier than mx plus b. That is it right there. If you are someone who really wants it to be mx plus b, you can do that. You just want to distribute your point slope form. So I need to do 75 times x and 75 times 5, 375. And then you see what we're really doing is we're taking away 375 from 1575. So we get 75x plus 1200. And you can check for yourself if that really does work out. How much would the painting be worth after 50 years? You just plug in 50 for x to your model. 75 times 50 plus 1200 means I have 75 times 50 is 3750 plus 1200. So we get 4950. Now, do I think that that's reasonable? I don't really know. I doubt that oil paintings go up at a linear rate. I bet that old stuff is worth more than new stuff, except if the people are totally forgotten. So I don't really know. Could be reasonable, could not be reasonable. Just depends. I don't know enough about paints. Okay, here we've got two different car companies. We're going to create a model comparing the two companies. One way to compare them is just to graph each of those models. If you graphed them, what you would notice is you've got one that starts lower but is steeper, and you've got another one that starts higher but is less steep. And so this is the Carnage one, the purple one, because it has a smaller slope and a higher y-intercept. Another option that I would accept for looking at a model here is just subtracting them. And if you just subtracted the two models, 70 minus 30 is 40, and 835 minus 12.5 is negative 4.15. So this right here is the difference in starting costs. And then this is the difference per day. Another option is to make a table where you're just saying days, first cost, second cost, 1 day, 2 days, etc. And you're just going through and calculating 42 and a half, 78.35, just calculating how much they're worth each day. This is essentially the same as doing what I did with the graphs. Around what date will the price be the same? When I ask you where the price is the same, you can either solve for the point of intersection here, you can make a table, or you can set your difference equal to 0, or you can set your two equations equal to each other. Works the same with all of those. What I want you to notice is really there's a $40 difference in starting costs, and there's about a $4 difference per day. So if you divide those, you know it takes about 10 days for them to cost the same amount. So if you do 40 divided by 4.15, you get 9.64, so about 10 days. Now, if your holiday is between 14 and 21 days, find an inequality in which the range shows the range in which the rental bill will lie. Two ways you can interpret this. One way is to give the cheapest possible costs. One way is to give the absolute cheapest and the absolute most expensive. But basically what you're doing is you're taking 14 and plugging it in for the days there, and taking 21 and plugging it in for both the days there. I know that because our break-even point was 10 days, I know that the cheaper one is going to be the one with the smaller slope. But I'll give you all the values just so you can see how to find all of the 4 different possible values, and then you can write your inequality that way. So I typed in, while I was talking, the first equation, plugging in 14 and 21, second equation, plugging in 14 and 21. The smallest number out of all of those is 186, and the biggest number out of all of those is 292. So one option here is 186.9 is smaller than or equal to your cost. I almost wrote the letter Y, which would have been fine. I'm just going to use the letter C because that's what was in the problem. And the biggest number is 292.5. All right, moving on down to the last one. We got a cute little sequence of matchsticks here. The important thing to notice is that there are 6 matchsticks at the beginning. And then when you tack on those extra shapes there, you've got 11 total, and then 16. So what I notice is that this is a sequence that started with 6 matchsticks, and it adds 5 matchsticks over and over and over again. Many of you don't like that, just like point slope form, even though I love it. Many of you still want to write 1 plus 5n or 5n plus 1. And the way you get the 1 there is if you work backwards and consider how many would there be when n is equal to 0. There'd be a single matchstick. So if you use that, then when n is equal to 7, it's just a simple plug in 7. So that gives you 35 plus 1, which is 36. Then for what value of n does the total number of matchsticks equal 626? That's when you write 626 equals 1 plus 5n. Take away 1 to get 625, and then divide by 5 to get 125. Then the last one, if you want to make 100 figures, again, that's just 1 plus 5 times 100, which is 501. Now you could also, though, have interpreted that last question as a series where you think the first one, you're going to leave it there, you're going to build the second one separately, you're going to build the third one separately. And in that case, you want to use your series formula, S100, where you're saying I have 100 terms. The first one takes 6 matchsticks. The 100th one will take 501 matchsticks. I just figured that out here. And dividing that by 2. So S100 then means 100 times 507 over 2, which becomes 25,350. So that's another way you could interpret that last question. So there you go. Please comment and let me know what was confusing, but those are the review stations we worked on.